Hello, my dear friends and followers. This is Abhishek. I welcome you to my channel Ayodhya Informative. In my previous video, I have started a first chapter of 10th, that is Arithmetic Progression. So in that video, I have given a definition of what is meant by arithmetic progression, what is common difference, and what is meant by a term, and what is infinite arithmetic progression and what is finite arithmetic progression. All these things I have discussed in my previous video. Who haven't watched that video, please go through that video. I have shared and I have provided that link in the description box. So in this video I am going to start with some examples. Along with that, exercise 1.1. And if you are watching my videos for the first time, don't forget to subscribe, share, like, and comment. In my previous video, I have given you the definition about what is meant by arithmetic progression. So, arithmetic progression is a list of numbers. So, arithmetic progression is list of numbers. So, let's take one example over here. 2, 4, 6, 8, 10. This is the list of numbers in which each term is obtained by adding fixed number to the preceding term is called as arithmetic progression. So also I have explained about what is term. In a sequence or in a list of numbers, each number is said to be a term. So here 2 is one term, 4 is one term, 6 is one term. Like this, every term, every number is said to be a one term. So it is like a arithmetic progression. If the common difference between two consecutive number is the same, then that sequence is said to be a arithmetic progression. And also I have given you a general form of arithmetic progression, that is how we can write a arithmetic progression in general form. How means, so here a plus d, a plus 2d, a plus 3d, so on. So it is the general form of arithmetic progression. In general form, we can write arithmetic progression as a plus d, a plus 2d, a plus 3d. So what is A? A is first term. In a sequence, a first term is indicated by a letter A. And what is D? D is the common difference. Difference between two numbers in a sequence, consecutive numbers. So it is the general form of arithmetic progression. So these things I have explained in my previous video. So today I will be starting and I will be solving some examples with exercise 1.1. So let's start with the first example of today. So that is example number 1. So for an AP 3 by 2, first question is for an AP 3 by 2, 1 by 2, minus 1 by 2, minus 3 by 2, so on. Write the first term and common difference. So they have given one sequence, one list of numbers. So from this number, we have to find or we have to write a first term and the difference between two consecutive numbers. So this is the question asked. So some students here one doubt arises that is this a sequence is an AP or not? So here we need not to find whether this sequence or whether this list of number is a arithmetic progression or not. Since in the question they have mentioned it is an AP, means it is a 100% 100% it is an arithmetic progression. So we need not go to find out it is an AP or not. So in the question only they have mentioned it, this list of number is arithmetic progression. Only our task is finding or writing a first term and common difference, that is A. So first term is indicated by A. So first term is 3 by 2, and the common difference is indicated by D. How we can find a common difference? A2 minus A1 means second term minus first term. Here second term, if you take for assumption, if it is a A1, if it is a A2, A3, A4, so on. So in order to find D, we have to subtract A2 minus A1. A2 minus A1. What is A2? A2 is 1 by 2. So 1 by 2 minus, what is A1? 3 by 2 minus 3 by 2. If you subtract these two numbers, we get answer as -1. How we got this -1? If you take a LCM, it is a 2. It is 1 minus 3. 1 minus 3 is -2 divided by 2. This is -1. So if this -1 is fixed between any two numbers, then this must be an arithmetic progression. Let's see another pair, that is A3 minus A2. So here what is A3? -1 by 2. A3 is -1 by 2. -1 by 2 minus, what is A2? 1 by 2. So if you see both signs are same, we need to add. So here half and half. What is half plus half? It is also 1. Half chapati plus half chapati is 1 chapati. 1. But the sign, what is sign? It is minus. Here the fixed number, common difference, -1 is fixed. It is a constant between any two numbers. Hence it is an arithmetic progression. So here, therefore, the first term is 3 by 2 and the common difference D is -1. This is the answer. This is the answer of first question. So let's move on to the second question. So second question. So here in this question, they have given 4 types of number list. So here, which of the following list of numbers forms an AP? Right next to two numbers. So first, here we need to find out whether a given sequence, whether a given number of list or list of numbers is AP or not. This is the first task we need to find out over here. So after finding if that given sequence is an arithmetic progression, then we need to write another two numbers, last two numbers. So let's see how we can solve these numbers. So the first sequence given is 4, 10, 16, 16 and 22, so on. So this is the arithmetic progression or not. We don't know whether it is arithmetic progression or not. So that is the task here. In the question they have asked, is this given sequence, is the given list of number forms an arithmetic progression, or it is an arithmetic progression or not. This is the first task. If this forms arithmetic progression, or if these numbers is in arithmetic progression, then we need to Write another two numbers, next two terms, next two numbers when it is only a arithmetic progression. So in order to find this is an arithmetic progression, there are two methods. One is normal and another one is general. So how we can check whether it is an arithmetic progression? Let's see. The first method I would say as so first method is, first we need to find a common difference. Common difference between these four numbers. Means let's, for our convenience, let's take 4 as A1, A2, A3 and 22 as A4. Now in the first method we need to find the difference between A2 and A1, A3 and A2, A4 and A3. If these differences are same, then this is an arithmetic progression. So see, A2 minus A1. What is A2 over here? A2 is 10 minus, what is A1? It is 4. 10 minus 4 is 6. So the next one, A3 minus A2. A3 minus A2. What is A3? The value of A3 is 16 and A3. A2 is 10. 16 minus 10 is 6. A4 minus A3. The next is A4 minus A3. A4 is 22. 16. 22 minus 16 is, it is also 6. Okay. See here. If we take a difference between these two numbers, the difference is same, 6, 6, 6, 6 over here. If this common difference, if this D is same, then we can say it is an arithmetic progression. So how we can write? Therefore, since common difference common difference D is same or is fixed, that is 6. Hence it is an arithmetic progression. Okay, if you call this a first method or first step, so hence it is an arithmetic progression. Since the D, the common difference between these numbers are same, hence we can say the given sequence is an arithmetic progression. Okay, this is the first step. So in the second step, what is the second step? In the second step, we need to write another two terms. If it is an arithmetic progression is the first step. After finding whether this is an arithmetic progression or not, next step is we need to write last two terms. How we can write? Here comes a general form of arithmetic progression. So we know that the general form of arithmetic progression is a a plus d, a plus 2d, a plus 3d, a plus 4d, a plus 5d, so on. So this is the general form of arithmetic progression. So if you consider or if you compare these two equations or these two sequences, here the first term is 4, second term a2 is 10, a plus d is 10, and a plus 2d is 16, a plus 3d is 22. In the question they have given we need to write these two terms. So that's why we need to find out a plus 4d. What is the value of a plus 4d and a plus 5d? So a plus 4d. What is a? A is the first term. In this given sequence, the first term is 4. That's why the value of a is 4 plus 4 into what is d. Here we have find out what is the value of d. It is 6. Now 4 plus 4 6 are 24. What is 24 plus 4? It is 28, isn't it? It is one term, and the last term is a plus 5d. So here a remains constant, that is 4. Here 4, here 5 into what is the value of d? D is 6. 4 plus 6 are 30. It is 34. Hence, the last two terms is 28 and 24. 24. This is the answer, final answer. So this is how we can check whether this is an arithmetic progression or not, and this is how we can write further terms by using this general form. Let's move on to the next question. So the next sequence is 1 minus 1. Second sequence is 1 minus 1 minus 3 minus 5, so on. So this is the sequence. Here also we need to find out what we have did in the previous question. First step is we need to check whether the given sequence or whether the given list of numbers is arithmetic progression or not. Let's see. So step number 1. In order to find out, we have to check the difference. So a2 minus a1. So what is a2? It is minus 1. What is a1? It is also 1. So minus 1 is minus 2. Let's check a3, a2. a3 minus a2. So what is a3? It is minus 2. A2 is minus 1. This is minus, and a2 is also minus 1 over here. So minus 3 as it is, minus into minus, it is plus, and 1. Minus 3 plus 1 is minus 2 again. Then last difference is minus a4 minus a3. What is a4? It is minus 5 minus this minus, not this minus. We have to consider this minus. Now minus 3, minus 5 as it is, minus into minus is plus, is also minus 2. So see here, the difference is fixed, that is constant in this sequence, hence the given sequence, so hence the list of number arithmetic progression. Since the common difference d is -2, which is fixed, hence given sequence is arithmetic progression. So this is the first step is completed. Here we have checked whether the difference between two consecutive number is the same or not. If it is same, then only the given sequence is arithmetic progression. Here the common difference d is -2, -2, -2. It is fixed. Hence the given sequence, hence the given list of number is said to be an arithmetic progression. If it is an arithmetic progression, then we need to write last two terms or another next two terms. So for that, we need to consider step number 2. In order to find out next two terms, we need to consider a general form of arithmetic progression, that is a plus d, a plus 2d, a plus 3d, a plus 4d, a plus 5d. So this is the general form. If you compare this form and with this, compare these two. Here in place of a, if you compare two, here the value of a, what is the value of a? It is 1. The value of a is 1. Here a is 1. And what is value of d? It is -2, -2, -2. Here the value of minus, we found that value, that d is -2. So after comparing these two equations, we found the value of a and value of d. Now a is -1, a plus d is -1, a plus 2d is -3, a plus 3d is -5. We need to find out, we need to write these two terms. So consider a plus 4d and a plus 5d. Now a plus 4d. So what is a? It is 1 plus 4, this 4 into what is d? It is -2. 1 plus 4 into -2, it is -8. So 1 plus into minus, what is plus into minus? It is -8. Then 1 minus 8 is, it is -7. It is this term. Now let's see last term, that is a plus 5d. A is -1, sorry, a is 1 plus 5 into what is d? It is -2. 1 plus 5 2s are 10. It is minus. So that's why it is -10. 1 plus into minus, it is -10. 1 minus 10. What is 1 minus 10? It is -9. A plus 5d is minus a plus 4d is -7. So the last two terms, the next two terms after -5 got the value as -7, and the next is -9. Now check whether the difference between these two values are same, whether we got -2 or not. So -7 minus of -5. minus 7 plus 5 is minus 2. Similarly, we also got minus 2. Like this, we have to find this and this. So let's move on to the next question. The third question given is minus 2 to minus 2 to minus 2. So this is the given sequence. Before going to start, we have to check whether the given list of numbers, whether the given series forms an arithmetic progression or. So here A1, here A2, this is A3, this is A4, this is A5. So first we need to take the difference between A2, A1, A3, A2, A4, A3, A5, A4. Let's check. So here A2 minus A1. What is A2? A2 is 2. This minus. What is A1? It is minus 2. Minus into minus, it is plus 2. That is, it is 4. Now, A3 minus A2. What is the value of A3? It is minus 2. And what is the value of A2? It is minus 2. Minus 2 minus 2. What is minus 2 minus 2? Minus 4. So see here, the difference between these two consecutive phases, it is not third. The first difference, first pair, the difference between the first pair of terms is 4 and the next pair of terms is minus 4. It is not same. Hence, the given sequence is not an arithmetic progression. Why? So see here, A3, A2 minus A1. This difference is not equal to A3 minus A1. Hence, given number or list of number, given sequence is not an AP. So this is simple. If these two values are same, then we move on to the next term, whether that is also same or not. Likewise, if these D are same, then only we have to say the given sequence forms an AP. But here, the first term, the difference between first consecutive is the next consecutive pair is minus 4. Hence, both are not equal. Then we can then it is not an AP. Next, we move on to the last question of example. After that, we have to solve the exercise 1.1. So the question is 111 222 333. So this is the given sequence. We need to check first whether the given sequence is arithmetic progression or not. If it's an arithmetic progression, only we need to get the next two. So check. 1. What is 1? It is A1, A2, A3, A4, A5, A6, so on. So see here. A2 minus A1. What is A2? What is the value of A2? 1. A1 is also 1. 1 minus 1 is 0. A2 minus A3. What is the value of A2? Sorry, A3. A3 minus A2. What is A3? It is 1 minus 1. It is also 0. A3 A4 minus A3. What is A4? It is 2. It is next one is 1. It is 1. See here, the difference between first two consecutive pair, the difference between the first two consecutive pair are same. Hence, apart from this, apart from these forms an arithmetic progression. But the next term, the difference between these two terms is 1. In this sequence, the difference between two consecutive pair is not same. Here, the D is not same or not fixed. Hence, this given sequence is not an arithmetic progression. So, these problems I have solved in notes. I also provide this in the description box. You can check. So, let's solve an exercise. Cut matter. Cut matter. Oi, Nina. Cut matter. Ali kati nanga kutat no. Let's start with first exercise, that is exercise 1.1. So here in this the first exercise of the first main, in that they have give in that they have given four sentences or four situations. So according to that four situations, from the following data we need to find out whether the given sentence forms an arithmetic progression or not. So let's see how we can find out. The first question is, in which of the following situation does the following list of numbers involved making an arithmetic progression and why? So here there are four situations or four sentences are given. So first we should read that question. First we should read that sentences carefully. So whether that sentences forms an arithmetic progression or not. If those sentences forms an arithmetic progression, then we need to give a reason why they form an arithmetic progression. So let's start with the first question. The taxi fare, the taxi fare after each kilometer after each kilometer when the fare is 15 rupees for first kilometer. First kilometer and 8 rupees for each additional kilometer and 8 rupees for each additional kilometer. So this is the sentence they have given. So from this sentence we need to form a one list of numbers. So first we need to understand what informations given in the sentence or situation. So from that sentence we need to form one number list or list of numbers or one sequence. So after forming that we need to check whether that sequence is in arithmetic progression or not. So let's get started with the solution part. before going to attempt, first we need to understand the question. So see here, there is one taxi. So the taxi fare after each kilometer, after 1 kilometer, when fare is 15 rupees. So there is a one taxi. So let's understand with a number line. So A is a one taxi, or let's call T is a taxi. So if you take a one taxi, so the fixed amount, if you travel through that taxi for 1 kilometer, for first kilometer, the fare is 15 rupees. Okay. For first kilometer. So if your distance, if your traveling distance is for 1 kilometer, then you need to pay a 15 rupees to the taxi. So then, if if you are traveling for more than 1 kilometer, let's say 15 kilometer or let's say 5 kilometers. So after first kilometer, for every 1 kilometer, you need to pay 8 rupees extra. So if you travel for 2 kilometer, then 215, you need to pay 8 rupees extra. If you travel for 3 kilometer, for third kilometer, this is second kilometer, this is third kilometer. If you travel 15 plus 8 is how much? This is 23. 23 plus 8. Like this, if you travel more than 1 kilometer, if you travel more than 1 kilometer, above 1 kilometer, then you need to pay 8 rupees extra for each kilometer, for each one kilometer. So that is the question. So let's form a one sequence through this sentence. So for the first kilometer, the amount is 15 rupees. Okay. So the second, if you travel for second kilometer, 1 kilometer extra. So let's solve with the general form. That is more simple to understand. So let's uh, consider one general form of arithmetic progression. So here A is first term, that is first kilometer. If you travel for the first kilometer, then the A should be 15. So here 1 is present. So A is 15 plus what is D? D is the distance traveled. Means here the difference, if you travel for 1 kilometer, then 1 into 8 additional extra kilometer. Then 15 for second additional, if you travel, then the amount D is 8, like this. 15, then 15, 8 ones are 8, 15 plus 2 8s are 16, so on. 15, 15 plus 8 is 23, then 15 plus 16 is 31. Okay. Now check if the difference between two consecutive number is same or not. If the consecutive difference between these two numbers, these two consecutive pair is same, then we say that the given sentence forms arithmetic progression. So see here, the difference between 23 and 15 is 8 and 31 and 23 is also 8. So here the two consecutive pair, if we subtract or if we take a difference between two consecutive numbers, then the difference is same, that is 8. Hence this sentence, hence this situation forms an arithmetic progression. So this is the solution for first question. So let's move on to the next question. So see here, the amount of air present in a cylinder, the amount of air present in cylinder when a vacuum pump removes one fourth of the air, one fourth of the air remaining in the cylinder at a time. So here the question, first we need to understand what the question is asking to find out and what the question is giving us data. So let's took one cylinder over here for better understanding. So if you imagine this is a cylinder, if you imagine this is a cylinder, we don't know the value at present what exactly air is present. So in that case we need to take or we need to assume the present or the air present is V or 1V. So then what they have given, if you attach a vacuum pump, so after removing air or after pumping the air using vacuum pump, it will remove one fourth of the remaining air. One fourth of, here we need to concentrate on one keyword. So here one fourth of the air. Okay, in a question, in a mathematical questions or in a mathematical situation, if you see a keyword of with one number, if you see a keyword of with a number, then you need to decide, we need to multiply. So here one fourth of the remaining air. So the initial remaining air is V. So if you remove one fourth of the air, one fourth of the air, so the remaining, initially the air present in that cylinder is V. So if you remove one fourth of the air, we need to minus or subtract. So from this V, we need to subtract one fourth of the air. One fourth of means multiply. Remaining air is V. So this is how we can find out the sequence. So I will tell you one more time. The present air containing or the air present in the cylinder initially is considered as V. So when you attach a vacuum pump, it will remove 1/4 of the air, 1/4 of the remaining air. So here, if you minus or if you subtract V by -4 from removing or presenting air is this much. So then how we can find out a sequence from this? Let's say, so let's take initial air present at the cylinder is initial air B V. So V is the initial air present in the cylinder. The total air whole present in the whole cylinder initially. So this is the total air. V is the total air present in the cylinder initially. So now, so if you attach a vacuum pump, it will remove 1/4 of the remaining air. So the air present after removing 1/4, the total air is V. If you subtract 1 minus 4, why we need to subtract from V, that from total air V, we have to take off or we have to remove 1/4. We have to remove, this is the total air present in the cylinder. From this air, we need to remove 1/4. 1/4 of what? 1/4 of remaining air. So this is the first air. So that means we need to multiply this. So V is the total air present in the cylinder. From that total air, we have to remove 1/4 of that particular air. Now, so what is, if we calculate this, if we find out this, how much we can get? That is 3 by 4V. Means if you take a LCM, it is 1, 3, this is 4. 3V minus, sorry, this is 4, this is 1. 4V minus 1V divided by 4, that is 3 by 4V. So this is the value. So 3 by 4 is the value. 3 by 4 V is the value when you remove 1/4 of the total air present in the cylinder. This is the remaining air. Now the cylinder consists of this much of air. Now, if you remove again 1/4 of the air, how much we can get? So this is the present air, 3 by 4V. From this total air, so from this we need to remove again 1/4 of the air using vacuum pump. So from this total V, from this 3 by 4 of V of air, we need to remove 1/4 of remaining air. Now after removing first 1/4, how much the air is remaining? That is 3 by 4. That's why we need to find out, or we should write it as 3 by 4 V. Now 3 by 4 V, 1 by 4, this is 3 by 16 V. Now the LCM is 16. Next 4 fours are 16 ones are. This is 12 minus 3, that is 9 by 16 v. So the first term is this, the second term is this. Now let's see. So we assume a present, initial air present in the cylinder is V. That's why it is considered as first term. So after removing 1/4 of the air, we get 3 by 4V. That is 3 by 4V. So if you remove again 1/4 of the air from this value, we get 9 by 16V. Now we get this is a sequence. So now the task is we need to find out whether these sequence is in arithmetic progression or not. How? Let's see. We need to take a difference over here. Now we need to take a difference over here. 3 by 4 v minus v. How much? Minus 1. It is 3 minus 4. It is minus 1 by 4. Now 9 by 16, if you assume it is A1, A2, A3, now A2 minus A1 is minus 1 by 4. Now A3 minus A2 will be, what is A3? 9 by 16 minus 3 by 4. The LCM is 16. Now 9 minus, it is 12. 9 minus 12 is minus 3 by 16. So see here, we got A2 minus A1 as minus 1 by 4. Then A3 minus A2 as minus 3 by 16. See here, the difference between two consecutive number. A2 minus A1 is minus 1 by 4. A3 minus A2 is minus 3 by 16. Since these two, the difference between these two consecutive number is not same, it is different. That's why this sentence not forms, or this sentence is not forms an arithmetic progression. So this is how we can solve. So if you have any doubt in this question, so let me know in the comment section. So I will explain this question once again. So this is all about this class. So then in the next class, I will start with another examples from this, that is third, fourth. If I continue those problems in this video, the length will be very large. That's why I will stop here only. So this is about today's video, and I will provide the PDF of this notes in the description box if you wanted that, if you read this and go through this notes. So if you have any doubt, then let me know in the comment section. So if don't forget to subscribe to my channel and share with your friends and comment, like and all. Thank you.